Good day, everyone. I'm Jessa Elano Barsanas from BSC 2J. Today, me and my group mates will be discussing about the lesson 12, the endogenic processes. But before we begin, let us first read the objectives, because this will serve as our guide as we go through on our lesson. This will serve as our scientific target. Okay? First, we will explain why the Earth's interior is hot. Then, we will describe how magma is formed. We will demonstrate what happens after magma is formed. And lastly, we will discuss the three main endogenic processes. So everyone, let us take a look at this scientific overview. Endogenic processes takes place within the earth but are responsible for the changes on the surface of the planet. These changes may include volcanic activity, tectonic plate movements, crustal deformation, isostatic adjustments, and magmatic intrusions. In magmatic intrusions includes silts, which form when magma intrudes between the rock layers, forming a horizontal or gently dipping sheet of igneous rock. Another one, the dikes, form when magma pushes up towards the surface through cracks in the rock. Dikes are vertical or stiffly dipping sheets of igneous rocks. Then lastly, the batholiths. These are a large, deep-seated intrusions, sometimes called plutons, that form as thick, viscous magma slowly makes its way towards the surface but seldom gets there. Studying these processes help us clearly understand why Earth's appearance has been undergoing constant remodeling. Let's come now to source of energy. Again, endogenic processes takes place within the Earth but are responsible for the changes on the surface of the planet. Source of energy of endogenous geological processes is from within the Earth itself. What do you think is the ultimate source of energy for these processes? You're right. Internal heat of the Earth. The internal heat of the Earth is the main power source of the endogenous processes that shape the planet's surface from within, meaning that the source of energy for these processes arises internally from the Earth. So imagine if we lost this internal heat, there might not have an endogenous geological processes that can occur, because again, it is a source of energy. With regards to the internal heat of the Earth, as part of it, what we have is the leftover heat, called the primordial heat. From the formation of our planet about 4.5 billion years ago, this is an accumulated heat release or formed during the early stages of the Earth's formation. This leftover internal heat is still being dissipated to the surface of our planet as part of the Earth's cooling down processes from how it was billions of years ago. When we say dissipating to the surface, this is the process of this internal heat being gradually released and dispersed from the Earth's interior towards the surface, meaning from the underground heat going to the top, which is the surface. Otherwise, since this primordial maintains the habitable condition of the Earth, we would not be able to survive on it. If there will be no or without this ongoing dissipation of the Earth's internal heat, the planet would become frozen, lifeless world like it is inhabitable. This primordial heat is critical factor that makes the Earth a suitable environment for life to thrive. But why does the Earth not cool down completely? The Earth has attained a stable temperature because it also continues to generate heat as fast as it is losing it. Other source of Earth's internal heat. We have radioactive decay of natural radioactive elements like U-238, U-235, TH-232, and K40 in the Earth's lithosphere from mantle and crust. This second type of heat is called radioactive heat. Many rocks in the crust and in the interior underground radioactive decay. The decay produces subatomic particles that move through the earth, and their energy of motion is converted into heat energy. It is estimated that the core of our planet is about 5,000 to 7,000 degrees Celsius and is as hot as the surface of the sun. Okay, trivia. One of the reasons why Earth is still dynamic while Mars is not anymore is the difference in the internal heat of the planets. Earth has substantial internal heat. This pertains to the significant amount of thermal energy present within the planet's interior, which is necessary in sustaining the dynamic and life-supporting environment on the Earth's surface. While Mars has relatively low internal heat flow, meaning this is one of the reasons why Mars does not support life, at least on the surface. The internal heat of the Earth flows towards the surface and powers the endogenous processes. The picture below shows the internal structure of the Earth and contribution of each layer to the overall heat flow in the entire globe. The entire core contributes about 22%, the lower mantle 32%, the upper mantle 22%, and the crust 24%. As to how heat flows or heat transfers, conduction is the mode from the inner to outer core. Since the inner core is solid, in the outer core, it is convection since it is liquid. In the lower and upper mantle, the process is convection. At the surface, the process is advection, although the arrows indicate an upward or vertical direction. The energy will be transferred or dissipated at the surface in a generally horizontal direction due to the action of, say, the wind or the atmosphere or ocean currents. It is estimated that both primordial heat and radiogenic heat contribute more or less equally to the total internal heat of the Earth. As the internal heat of the planet reaches the surface, the areas or places where they come out in greater amount would be in plate boundaries as how in the image. The red portions are hotter areas. These are the mid-oceanic ridges and oceanic crust. These are places where the Earth's internal heat comes out the most and are therefore active areas of endogenous processes. Now, let's come now to the types of endogenic processes, and there are three, which is the folding, faulting, volcanism. The following members of this topic, endogenic processes, will be the one to continue this discussion. Again, I'm Jessa Ilano Barsanas. I hope you have learned something. Thank you.